Namaste. Welcome to the video lecture series on the chapter Periodic Table of an Element. In this video, that is video number 10, we are going to study about some characteristic properties of group 1 element, that is first group element or first A element, which are commonly known as alkali metal, So here I have a list of group 1 element, that is lithium, sodium, potassium, rubidium, cesium and francium. Out of this, francium is radioactive element. And against that I have written down its electronic configuration and atomic number. Now, first of all, the very first question comes, that is why this element we call it as an alkali metal. Now group 1 element or 1A element are generally called as alkali metals because these elements react with water to produce water soluble base. This element reacts with water to produce water soluble base, which is called as alkali. That's why these elements we call it as an alkali metal. Now, these metals are generally white solid. They are soft. Okay, so you can easily cut them with the help of knife. These elements which are present as an alkali metal, they are white and very soft. You can cut with the help of knife. Now, as you observe, all these elements are placed in first group because they got one electron in its outermost shell. So if you look at here in the electronic configuration, all the elements have got one electron in its valence shell. Now as they got free electron, so they are generally good conductor of electricity and heat. They are good conductor of heat and electricity we can have. Now, one interesting feature is been seen. As we move from top to bottom, that means as we go down the group, the atomic size goes on increasing. Because every time you observe that the electron is added in new shell. For example, lithium, I have 2 shells. For lithium, I have 2 shells. For potassium, I have 4 shells. For sodium, I have 3 shells. For cesium, I have 2 to 4 and 6. So you observe that as I move from top to bottom, the number of shell goes on increasing. Hence, a distance from the center of the nucleus to the outermost shell goes on increasing. Hence, a distance from the center of the nucleus to the outermost shell goes on increasing. Now, as this element possesses larger size, so they do show a tendency to lose electron very quickly. And forms a positively charged ion. So let me have sodium, which will lose 1 electron from its valence shell and gets converted into positively charged sodium ion. Potassium will also show a tendency to lose one of the electron from its valence shell, okay, and gets converted into K+1 ion. So here all these elements, because of their larger size, they readily lose electron and forms monovalent cation, that is positively charged ion. Because of this particular nature, these are called as metallic element or electropositive element, and this electropositivity, that is tendency to lose electron readily and forms positively charged ion, goes on increasing from top to bottom. You will observe that cesium will lose electron very quickly because of its larger size. Then I have this element, because of its larger size, they lose their valence electron very readily. That's why they act as a good reducing agent. So what is reducing agent? Reducing agent is that substance which itself undergoes oxidation. As this element, you observe, they readily undergo oxidation. That's why they act as a good reducing agent. Now, here The reactivity also goes on increasing from top to bottom because size goes on increasing, and we'll observe that this element acts as a good reducing agent. This element acts as a good reducing agent. Now, this element, why we call them alkali? So I'll explain here. This element generally react with water. This element generally react with water and results in formation of corresponding metal hydroxide. And this metal hydroxides are soluble in water. These metal hydroxides are soluble in water. We call them as an alkali. And along with this, it evolves a hydrogen gas. Along with this, it evolves a hydrogen gas. So let me take a simple example here. Sodium metal. When I react with water, if you drop a piece of sodium metal in water, it reacts very violently, forms corresponding sodium hydroxide, and evolves hydrogen gas. So to balance this, I'll have 2Na, 2H2O gives me 2NaOH plus H2. So here this is sodium hydroxide, which is an alkali, that is water soluble base. Okay. Now, same way I can have a potassium metal also reacts with water and gets converted into potassium hydroxide and evolves hydrogen gas. To balance this, I'll multiply potassium by 2, water by 2 and 2 KOH. Then this element reacts with hydrogen so as to form corresponding metal hydrides. This is very important. This element shows a tendency to react with hydrogen and results in formation of corresponding hydride. And tendency to form hydride goes on decreasing from top to bottom. Why? Because cesium has got larger size and hydrogen has got very smaller size. So the effective bonding or the force of attraction may not take place. So on account of that, the tendency to form an hydride goes on decreasing from top to bottom. So let me have lithium reacts with hydrogen so as to give me lithium hydride. So to balance this, I'll multiply by 2. Sodium reacts with hydrogen in order to give me sodium hydride. Okay. Potassium reacts with hydrogen so as to give me potassium hydride. Okay. Now, these hydrides are basically ionic in nature. Here, the metal, alkali metal, will have positive valency and hydrogen will have negative valency. So I have sodium hydride if I write it. So it is Na plus 1, H minus 1. Okay. Now, these metals generally show a tendency to react readily with air. Because of their tendency to lose electron very quickly, they get oxidized. So they do combine with atmospheric oxygen, and due to that, it forms an oxide layer on its surface. As they form an oxide layer on its surface, the surface gets easily tarnished. That means the shining has been lost. And because of this particular reactive nature, we have these metals are always stored in either paraffin or in kerosene. I cannot store them in water. The very first thing, its density is less than water. Secondly, they react very violently with water. I cannot have that reaction. I cannot keep this metal with water. When I keep them in paraffin wax or when I keep them in kerosene, their density is more. So they immediately move down. So their contact with atmospheric air can be cut off easily. So let me have sodium metal combines with atmospheric oxygen in order to give me corresponding sodium oxide, which tarnishes its surface. So to prevent this reaction, we are generally storing potassium, sodium, all this reactive metal in kerosene or in paraffin wax. Then we have these elements. They generally react with chlorine. Now, chlorine is a non-metal and is a reactive metal. So these elements do react with chlorine gas in order to give corresponding metallic chloride. And these metal chlorides are ionic in nature. So I have a sodium metal reacts with chlorine in order to give me sodium chloride, and we have studied in the atomic structure and chemical bonding, there we have shown that sodium chloride is ionic in nature. Sodium chloride is ionic in nature. Sodium loses electron, chlorine gains electron. I have a potassium metal combines with chlorine gas in order to give me potassium chloride. I have cesium metal may react with chlorine in order to give me cesium chloride. Okay, in order to give me cesium chloride. So this is all these particular compounds like sodium chloride, potassium chloride, cesium chloride, any alkali metal chloride which you form, they are found as an ionic compound. They are ionic compound formed by transfer of electron from metal to chlorine. So these are the few characteristics of alkali metal, that is group 1 element. Hope you must have understood. Thank you for watching.